So as we continue these problems, we'll see numbers 3 and 4. In each of these problems, we have to draw an angle bisector and then determine which point that angle bisector passes through. Okay, so the answer to this question is going to be the letter of the point that the angle bisector passes through. And we are supposed to do these problems with our protractor. Now, we could do it with a compass as well. We could construct an angle bisector with our compass, but in this case, the purpose of this exercise is to practice using the protractor. Now let's zoom in on problem 3, and you'll notice that I took the liberty of extending this line using a straight edge so that it would be easier to use the protractor. Let's go ahead. Let's line up the origin with the vertex. Let's line up the baseline with the side of the angle, and let's get a reading on the size of this angle. Okay, so we've got 45, 46, 47. We've got about a 47-degree angle here. Okay, so this angle is 47 degrees. And the angle bisector is going to cut through this angle at exactly at an angle that is half of 47. So what we've got to do is we've got to calculate 47 divided by 2. Okay, 47 divided by 2 is 23.5. So we've got to basically construct an angle starting from the bottom of the angle, this ray here, the ray that's horizontal in this image, and construct an angle that's 23.5 degrees in measure, and then see when we construct that angle exactly what point the ray goes through. So let's go ahead and let's construct an angle. Let's learn how to construct an angle using a protractor. So to do that, we have to line up our origin, line up our baseline. It does take a bit of practice to do that perfectly well. And now we have to construct an angle that is 23.5 degrees, exactly 23.5 degrees large. Well, we do have a little bit of a problem here because 23.5 is about over there, but we can't really get through the protractor to be able to draw it. Okay, so we're going to do something slightly different. We're going to count off on the outer side here 23.5 degrees because that's the same thing. We're going to be able to count off 23.5 degrees on our clockwise outer scale, and we're going to sort of improvise. So from 180 to 170 is 20 degrees. From 170 to 160 is, from 180 to 170 is 10 degrees. And then from 170 to 160 is 20 degrees. And then from this point, we've got to do another 3.5 degrees. So we'll do another 1, 2, 3.5. So that's exactly where our point's going to be. So whatever the ray goes through that goes between these 2 points, whichever point is in that ray will be the answer to the problem. So now I'm lining up my straight edge. I'm drawing my ray. And you can see that we are going through point A. So this angle here is 23.5 degrees. And this angle, which is equal to this angle, is also 23.5 degrees. They add up to 47 degrees, and the angle bisector goes through point A. Okay, very nice. Let's go to our second problem, and let's do the same thing. Again, we have to figure out which point the angle bisector will go through. So let's see how we'll do this one. Again, we're going to line up our origin with the vertex. We're going to put the baseline of our protractor parallel to the ray. And now we're going to have to measure this angle. So let's go ahead and focus in and see exactly what we've got. Well, we've got another 112-degree angle here. Okay, so this is 110, 111, 112. Okay, we're using the inner anti-clockwise, counterclockwise scale. So this, which is obviously an obtuse angle, right? This is obviously an obtuse angle. In fact, it's the same size as the angle directly above it. And they do look about the same size. This is 112 degrees. So the angle bisector is going to be some ray which is going to go through the same vertex, but is going to be making an angle of half of that with each side of the angle. So we have to take 112 divided by 2, and that's going to give us, what's 112 divided by 2? Be 56. Okay, 56 degrees. So we now have to construct, using our protractor, a 56 degree angle in order to be able to find our angle bisector. Now, I'm going to construct this angle of 56 degrees a little bit different than I did the other one, just to show you there's another way to do this. So I was using this bottom line, and I had to sort of improvise using the anti-clockwise scale. Here, I'm going to actually construct it on this line. I'm going to line up my origin with my vertex. I'm going to then line up my baseline with my ray, and I'm going to look along the clockwise scale for 56 degrees. And I think you'll see, along with me, that 56 degrees is right about there. This is 50, this is 55, this is 60. 56 would be just about, let me zoom in even a little bit closer. Be right about here. Okay, so you see you can actually use either the clockwise or the counterclockwise scale. So now that we have ourselves our point up here, and we've got to make sure that this is the point we just drew. Let me put a little circle around it so we know it. I'm going to now take my straight edge. I'm now going to connect that point to the point of my vertex here, and go ahead, construct my angle bisector, and we see it goes right through point X. Okay, so if we take a look at our angle, we've got ourselves an angle bisector. This angle is equal to this angle. Okay, and each of the lengths of these angles is 56 degrees. Okay, the next video we will actually construct an angle bisector both using a compass and using a protractor.